Now we'll look at the binomial theorem. The binomial theorem gives us a way to expand a binomial that's being raised to a power. A binomial, remember, is a two-termed polynomial, and if that two-termed polynomial is being raised to a power, we can use the binomial theorem. We're going to start with a simple one, x plus y to the fourth power. The first thing you have to do is to create a Pascal's triangle. And if you need to review that, I have a video on creating the Pascal's triangle. Now we only need to create it up into the point where we have a 4 in that second diagonal. And when we have a 4 there, that matches the fourth power. When we get to that row, that's the row that we're going to focus on. What those numbers represent, amongst other things, is all the coefficients that will be in front of each term of this binomial expansion. What I mean by expanding the binomial, let's do it. Let's show you how it would work the long way. If we were asked to take this to the fourth power, we could write x plus y plus x plus y plus x plus y plus x plus y. We could FOIL two of them and then multiply that by the third one and then multiply that by the fourth one, and that's going to take a while, but it could be done like that. But this is a shortcut method, and what it tells you is you can take these numbers and put them as the coefficients in front of each term. And what I'm going to do is I'm going to separate each term with the coefficient and two parentheses, and I'll show you why in a minute. You'll always start your binomial expansion like this: the coefficients from the proper row of Pascal's triangle, followed by two sets of parentheses. The next step is to take the first term in your binomial and write it in the first parentheses of each set. The next step is to take the second term of your binomial, and note that the sign in front of it also needs to be considered. So if that was a minus y, we would put negative y in each of the parentheses. But this is a positive y, so we're just going to write y in each of the second parentheses. Second term goes in the second parentheses. The next step is to put exponents on each of your parentheses. We're going to start with the parentheses that have the x's in them, and we're going to start with the highest power that we have, which is the power of 4, the exponent that was on the binomial. That's going to be the highest number, and we're going to go down by 1 each time until we get down to 0. So those are going to be the exponents on the x, or the first parentheses. You go 4, 3, 2, 1, 0, always starting with whatever this power is. So if it was 6, you go 6, 5, 4, 3, 2, 1, 0. Now, the second parentheses with the y in it will actually go in reverse of that. So then you'll start with 0 and go up to 1, 2, 3, 4, and you should end with the number that's in the exponent. Now let's simplify this polynomial. I would take each term one at a time and analyze it. So we basically have a 1 times x to the fourth power, and y to the 0 is just 1. Anything to the 0 power is just 1. So if we multiply those three things, we can write our first term as x to the fourth. Then we go to our second term. We have a 4. X is being raised to the third power. Y is being raised to the first power, which just means it's y. And so when we multiply those three, we get 4x cubed y. Then we go to our third term, and we have 6x squared y squared. Nothing unusual about that one. Our fourth term is 4 times x to the first, which we could just write as x, and y cubed. So we'll write 4x y cubed. Our last term is 1 times, well, we've got x to the 0, which is also a whole number 1. Anything to the 0 is 1. And then we have y to the 4th. So that makes 1y to the 4th, which we can just write as y to the 4th power. So this is our final answer after using Pascal's triangle and the binomial theorem to expand the binomial that was x plus y to the 4th power.